Hello. Now it's fine, I think.
Yes, sir. Yes, sir.
Okay, fine. Thank you. So let me share my screen. Okay. So actually, this is the third week assignment class. Okay. So basically, your due date on 14th of February. So before that, you need to submit your assignments. So let's after gone through the brief what you have done in this week three. So week three all about the basic block diagram reduction, signal flow graph. Okay. So how we can solve the block diagram and how we'll convert the block diagram into signal flow graph, okay? And how you solve signal flow graph by using Mason's-Sken formula and find out the transfer function. So because this part, the first part, that is block diagram reduction and signal flow graph is very important, okay? Why it's important? Actually, it will help you to solve many questions which is further like time domain analysis in frequency domain analysis you have to find out the transfer function. So in a differential equation how you last class you have converted into Laplace domain and find out the transfer function. So here you have to model the plant, and the plant is modeled by using some blocks, and you have to solve that block diagram, and also that block diagram in electrical flow electrical form is represented in signal flow, so that you can solve by using some Mason's gain formula, and you have to find the transfer function. So that part is already over in the week 3 in the tutorial. And also it has covered that the time domain analysis, it covers how the system responds, okay, to various types of input. So there are some standard input like impulse input, step input, parabolic input. So how the system will behave by varying these inputs. Okay. Also to some time domain specification like how a step order system will behave to a second order system, how its settling time, rise time, okay, delay time, all these peak overshoot. So all these things have already covered. So now here in week 3 we are going to solve some of the problems. I will also tell you how to approach the problems, okay, how to solve the problem in smarter way, and not only the formulas way, some smarter way. And also I will save your time that how can you quickly solve the problems. Okay, that's the motive in our this class. So I think you have all of you have gone through the week 3 lectures and have some idea about block diagram reduction, signal flow graph, how you use Mason's-Sken formula. So you have some idea, then I can start the problem directly. Okay, so let me clarify. Have you gone through the lectures? I'm just asking a question, kindly reply.
Yes, sir. Yes, sir. Yes, sir. Yes, sir.
Okay, fine. So that's good actually. I just so just I have taken a few questions today, like 7 8 questions, but I will solve numerous questions today. Okay, so not around 10 questions, you can solve around 20 30 questions. Okay, some smarter way I'll solve you, but I have not just have not updated all my PPT, but I will write down here. So let's go to the first question. Let me check anyone is there. Thank you. Now let me make it full slide. Yeah. So this is a block diagram. Okay, a plant is modeled by using some differentiators. S is a differentiator, 1 by S is an integrator. Okay, so a plant is modeled like that. You have to find out the Y of S with respect to the input U of S. So how you solve this problem? So what is the first step? What is the first step to solve this problem? So I'm using Mason's gain formula. Otherwise, what you can do that you can convert this
Sir,
block diagram.
please screen small big side.
Uh, so you want a smaller size?
Question not read.
Question is not readable.
मतलब
Please
small
enlarge, sir. Enlarge the. Please expand, sir. Zoom out.
zoom out. Yes.
Now it's fine.
No, sir. No. Actually, screen is occupied with other things, sir. Except
Okay. Now it's visible.
main visible, sir. Just little more zooming is required,
Okay.
sir.
Actually, this question I have taken from books. Okay. So that's why this is a picture. So maybe okay. I'm just writing down. Okay, for you. Yes, I'm drawing the figure. Okay. So what is there? It is there. The summation block is there. So here and some input is I'm applying u of s. Okay, and here from here there is a differentiator. Differentiator is represented in Laplace domain by s, and also one integrator is there, is represented by 1 by s, and also again one summing block is there. Okay, where both are getting added up, both are having plus sign, and from this integrator, from this summing point, another integrator is there 1 by s. Now this is whole output y of s, and there are some feedback loops is there. From this point, one feedback loop is going back to this summing point as a negative sign. Also another feedback from output to again input. This is one feedback loop. Now it is clear.
Yes, sir.
Sir,
Okay.
yes. Sir, picture is earlier also clear, sir, but whatever is written is not readable, sir. That
Okay.
visible.
Okay. Now you can now how to solve this question. So how will you solve this question? Suppose this question is in front of you. You have the time of 2 minutes maximum. Then how you are going to solve this question? So the technique to solve this question is that the Mason's gain formula should be in your mind. Okay. So Mason's gain formula, you have to play with around uh, 15-10 questions so that you can have a feel of this Mason's gain formula. So it says that some output by input is nothing but it depends upon some forward path. Okay, P1 del 1 plus P2 del 2 like that plus dot 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 divided by summation of delta. So you know P1 is the number of forward path. Okay, P2 is the number of forward path. Delta 1 is the corresponding loop which is not touching that forward path. Okay, and the whole delta is the total loop gain. Okay, so this formula you should have to incorporate in your mind. Then you can solve this question in one line. I don't need to write a lot of line to solve this question. So only thing you need to find out what is how many number of forward path are there. First of all, how many number of forward path, how many number of forward path. Okay, second is that number of total loop gain you have to find out delta. Okay, delta you have to find out. Then third point, that this delta 1 and delta 2 is the loop gain which is not touching the corresponding forward path. Okay, suppose P1 is a forward path, then this delta 1 should not touch P1 at any point of time. It is a different loop which is not touching P1. Similarly, delta 2 is a loop gain which is not touching second forward path which is P2, like that. So this is a simple concept. So one way, just let me. So how many of you can solve this question in one line? That's my point. Solving it in 5 lines is okay, but how can you solve in one line? Escape something. Just remove this one. I will just solve it on the top. So how you solve this question? You just write down in one line. You can solve this question: y of s divided by u of s. Okay, y of s divided by u of s. So how many forward paths? Can anyone tell me how many forward paths are there? So this s plus 1 by s is having one summing block. Okay, so you can replace this s plus 1 by s by, because there are two parallel paths which are adding off. So I can remove this. I am removing this one. So let me use my eraser.
Sir, without using reduction, block reduction technique, can you directly solve using?
No, I'm not using any block reduction. I'm not okay. I'm not using any block diagram reduction technique. I'm just simplifying this question first. I'm just simplifying. Let me What I'm doing here, I'm just removing this s plus 1 by s. I'm just writing here in place of this one. I'm just writing this. I'm not removing because there are two parallel paths, so I'm just making it one parallel. Now the question is very easy. You can write down in one line. So how many forward paths are there? Only one forward path, having a forward loop gain how much? S plus 1 by s. Right, sir?
Yes, sir.
Now, after writing this forward path, forget about delta 1, delta 2. You just write the denominator part, okay? What is the denominator part? Is the combination of all the loop gain, okay? So in Masson gain formula, it's denoted by 1 minus, okay? What is this minus sign? Whenever minus sign is there and plus sign is there, minus sign means individual loop gain, plus sign means product of two individual loop gain which are non-touching. Similarly, again minus means product of three non-touching loop, because when odd number is coming you have to put a minus, when even number is coming you have to take a plus. So it means first of all we have to identify how many number of individual loops are there. Individual loops means single loop. So how many individual loops are there? So here is one loop L1, I am saying L1, and here is another loop, this one is L2, right? Are you clear? L1 and
Yes, sir.
L2. So now
Yes,
you
sir.
write down the individual loop gain. So I'm writing here, I'm not solving because you know what is L1. So what one is L1. So here this loop gain is minus L1 because this minus sign is there. So here minus L1, and here is again L2 is something, again this minus sign is there, so minus L2. So I have written. So again I need to check that whether there are these two loops are there. There is no other loops are there. But is these two loops are independent each other? Means there is no common point touching? No. Means if this point is common to both the loops. Okay. So they are not touching loops. So again another second term will be 0, and that's it. After writing this, you have come across the total loop gain. So delta is calculated. Now you have to find out delta 1. Delta 1 is means, suppose take the fast forward path. Only one forward path is there. So take that forward path and see that which loop is non-touching, not touching any point on that forward path. So all the loop L1 and L2 are touching every point of this forward path. Okay, L1 is touching at this point, L2 is touching everywhere. So it means delta 1. Okay, so delta 1 is 1. Okay, so similarly one forward path is there, so P2 delta 2 is not exist. So this is your answer.
Sir, what is the forward path and backward path?
So forward path means so forward path means where the arrow is going to input to output. See here, sir, means here the arrow is going in, this is going up to this y of s. So this is called a forward path. Backward path means suppose I have started this point, then there is some path exists at which I can reach at the same point again. So here you see this black color will be trace and the arrow is here, so it is again coming and reaching at the black point. So this is a loop. So this is called a negative feedback loop because the sign is negative. Okay, you are going backward path.
Sir, forward path one way is also to be multiplied, sir.
Yeah, this one way is also there. Yeah, you are saying. So this is the simplest problem I have taken. If I'll give you some complex problem where number of forward paths are 2 and 3, number of loops will be 5 and 6. So how you write in one line, that's the capability you have in block diagram or signal flow graph you have. Okay, so that's the technique. You have to just remember this Mason's gain formula in your mind. So and you have to know that what is delta. Delta is always no problem for anyone to find out. But the tricky part is that delta 1 need to find out. Delta 1 is something which is not touching that corresponding forward path. It means here P1 is only one forward path, which gain is s plus 1 by s into 1 by s. So you have to check that all the loops L1, L2, are this L1 and L2 are touching that forward path or not touching. If it is not touching, then the loop will be counted here. Means delta 1 will coming something. Delta 1, of course, delta 1 is a part of delta. Okay, so I'll show you that how you have to go to a complex problem, how you can find out that. So I think this basic problem you have to know how to solve this. This is a simple problem I have taken now. It's clear?
Sir, please could you solve this problem by block reduction so that we will get more idea.
Means sorry sir, reduction means
Just by not going by Maximum gain formula, just first principle, sir. Just by summing, by taking feedbacks and like that.
mm, okay. You have any problem, then you can share me. But I have taken this problem you can solve in one line. How can you solve in one line this problem? You will go to question number 2. How you solve this question? Of course, sir, in block diagram reduction signal flow graph, you have to apply Mason's formula. There is no other shortcut. But how you smartly apply Mason's formula, that's important. Means if one person will write down L1, L2, L3, L4 and P1 delta 1, P2 delta 2 multiply and everything, it will take hardly 5-10 minutes to solve any problem. So, but how smartly you can apply Mason's formula? That's the point you need to learn. Okay, is this question is visible?
It's very small figure.
Okay. It's not visible, but it is visible to me clearly. Second step. Okay.
In our case, screen is 1/4, sir. For you, it will be complete screen.
Okay. Okay. Now it's clear.
Yes, sir.
Okay, sir. Okay.
Alright. Just to write down the question on your pen and paper, then I'll just solve you how to solve these questions. Okay. So can anybody write down direct delta how much? How is delta you have to write down? Individual loops. How many individual loops are there here? How many individual loops are there? You have to find out loops means at which node you have to start and reach at the same node. Okay. So let me identify this one is L1, this one is L2, this one is L3, this one is L4. There are 4 loops. I can see 4 number of loops are there. Suppose I write down what is L1. L1 is something -2. What is L2? L2 is G4 and -9, so minus G4. What is L3? L3 is G3, G4 with a minus. Okay, G3, G4 with a negative sign. What is L4? L4 is this loop. Okay, G2, G3, G4 again -1. So minus G2, G3, G4. These are the 4 independent loops. Okay, now you have to find out which loops are out of these 4 loops, which 2 loops are non-touching. Non-touching, you can say L1 and L2 are non-touching.
Yes, sir.
So L1, L2, 2 non-touching loops. Again, anything else? L1 and L3 also.
Yes.
L1 and L3 also 2 non-touching loops. After finding out all this, is there any 3 loops which are non-touching each other? No, cannot find it. L2, L3 common is there. L1, I am not seeing. Okay, no. So maximum, these are the 2 loops. Next, you can find out delta easily. So how much delta is? 1 minus of L1 minus of L2 minus L3 minus L4. Okay, then plus L1 L2 plus L1 L3. These are the delta. Next point is that how many forward paths are there. So only one forward path you can see. The corresponding straight line is only one forward path. Okay. So only one forward path P1 is there. So G1, G2, G3, G4. And you have to check that in this forward path, which loop is non-touching. Which loop is non-touching? All the loops are touching that forward path. So delta 1 is by default. Because all the loops are touching, L1 is touching, L2 is touching, so it will be 0. L3 is touching, it is 0. L4 is touching, 0. L1, L2 product is touching, L1, L3 product is touching. So all these values are 0. So what is remaining? Only 1 is remaining. That's why this delta 1 is 1. Is it clear?
Yes, sir.
So in this way you have to solve the problem. But let me write down one question for you. Let's say, just I'm creating one problem for you. Let's say this is G1 and this is G2, this is G3, this is your input U and this is your output Y. So let's say some disturbance is coming here, D of S or D1, whatever. Yes. So in this case, and so let's say one feedback is coming at this point. This is negative feedback minus 1. Right. So suppose in this question somebody will ask you to find out disturbance input D is input with respect to Y. Then how you solve this question? What is the idea of solving this question?
Sir, at a time we take one. If we want to find by considering disturbance, then U will 0.
Okay, that's good. But my approach of solving how this question is that if it is to find out Y by D1, in some cases, okay, so here the output is Y, but input is not U. Input is D1. So how you can write this? Because suppose Y by U you know, okay, Y by U you know, then to find out U by D1, also this product you can do. This is also one method of solving question. So why I'm saying that sometimes finding this Y by U is easy for you rather than finding D by U or something Y by D, and this U by D also, U is your you can find out this one is input and this is output. So just inverse it. You will find out U by D1. Okay, this is your output and this is your input. So this is not the case. I am just showing an example that sometimes at some middle point they are finding out to ask. I have seen some problems like that. But if you have problem, then you can send me. I this method will be very helpful there. Just break down that point, node point. It may not be the case here because you cannot find out U by D1, because U by D1 there is no forward path. Okay, so this is not the question I am exactly saying, but there are some questions where you can find out the input is not the input here, the input is a middle point, then you can break that Y with respect to D1 or D1 with respect to some other point, like that also you can do. Otherwise somebody has told that actually you can apply superposition, you take one input at a time and solve the question. When you are applying D1 with respect to Y, you have to take U0, and similarly when you are finding out D1 0 and with respect to Y, and you have to cascade like that, means addition. So that thing you can do also. So block diagram and signal flow graph, the smartest way you have to solve by using Mason's formula, but you have to think. You should not miss any loop, and you should not. These people are mistake in finding out del 1 and del 2. Okay, so that is the tricky part. So if you have any question from your side, then I can solve. Otherwise, I'll move forward because this part I'm not thinking it is little bit easier for you to solve.
Sir, one query, sir, regarding question number 2.
Right, right,
When you find the delta,
right.
delta equals to 1 minus in bracket. sum of individual loop gains.
Right.
Again, we have put the minus L1 minus L2. Already we have put the value of L1 minus 2.
Uh, L1 minus 2. Yeah, yes, sir. This is actually, this is I'm not saying. This is Mason's gain is saying that whenever individual loop is there, you have to put a minus sign.
Okay? Already we put the value
Oh,
of
I'm
L1
sorry,
minus
sorry,
2.
sorry, sir. Right, right. These are plus. Okay, already
Yes,
have
yes.
taken minus. Okay, so thank you, sir.
Also in question number one, same things. I thought
Yeah, yeah.
there's some trick.
Okay, no, 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 sir. Right, you are right. This
Okay.
minus already have taken common. This is my clarification.
Sir, this is every other, matlab every question different type transfer functions.
Which one you are saying?
This is transfer function, na?
Right, right, right.
matlab last question is different transfer function. This is different transfer function.
Yeah, last question I just told you that actually suppose if you have taken output y not at the in means transfer function is not with respect to u, the transfer function is with respect to some other point in that path, like here d1 you can say, like here you need to find out, like suppose you know that steady state error you, okay, so whenever you're finding out steady state error, so suppose if I model your plant, this is your g of s, let's say this is your some gain, some input is coming, input, let me take it as input, let me take it as output. So here is some sensor, the sensor actually we are modeling, okay, so this is just amplifying, and here let's say a buck converter, okay, here your output voltage is v naught, I'm sensing that voltage, okay, I'm sensing that voltage, I'm having a sensor, the sensor is having a gain h of s, now you are giving that to feedback to the reference signal which is your input. So let's make this is plus and minus, this error is coming as e of s. Now here, if suppose you know that you need to find out this e of s, so how you find out e of s with respect to input u of s,
Okay. It means, sir, our servo motor, one encoder is connected.
right?
So this type transfer function we have solved the actual.
Yeah, somebody can do like that. How you find out? You know that your error e of s is nothing but your output lets me y of s or input is u of s. So one person can do also in this fashion, but here means after finding out, you can directly find out e of s by u of s. Not you have to find out y of s, and after finding out y of s you have to need to subtract from e of s, you will get e of s. So how you directly find out, this is also I'm saying that any middle point, if you need to find out the transfer function, how will you do that?
Okay.
Now you can try yourself. Let's say this finding out this steady state error, this is an important question. Why I'm saying that, because this type of system mostly we're using for the closed loop control, okay, to finding out the steady state error, okay. So how you do solve this question? Suppose I'm saying what is output y of s by input u of s, can you write down here directly? How can I directly write down? How many forward paths are there? G of s, only one forward path is there. How many loops are there? Only one loop is there. So 1 minus, this is a negative sign. So minus g into h. So this will be g divided by 1 plus gh. Right, sir?
Sir, excuse me, sir.
Right. Yeah.
Sir, in first and second problems, whatever you written is right, sir. One minus of that gain is minus, so it should be plus.
What I'm
Please,
saying, that is correct.
yes, sir. Yes, sir. Later you change it to minus plus. Then it will be plus.
Okay, okay, okay. You just check the formula. Actually, I have remembered the concept that actually when individual loop is there, I have to put a minus. When two terms
Sir,
are there, I need to product it. I have to take a plus.
yes, sir. Yes, sir. Individual loop is minus, sir. Then it one minus will be before, so it will be plus.
Right, right. That's the formula. You just remember. Okay, no problem.
Okay, sir. Okay.
So now here you get the output y of s, right, sir?
Yes, sir.
Okay.
Yes, yes.
Now tell me how you find out E of S by U of S. You got Y of S by U of S. Now how will you find out E of S by U of S? Because my target is that I need to find out this error, not output by input. I need to find out E of S divided by U of S. So directly you find out the first case is that transfer function, output by input. But I am saying that you need to find out at any middle point. Let's say this middle point is E of S, E of S by U of S. So how will you
Sir,
do that?
E of S is error and U of S is
Input.
okay.
This is your input, E of S. Everybody know that actually you can see how many forward paths are there, sir, from input to E of S. If you want to reach input here and you have to end up here, then you have to just cross this arrow, okay, here to here. Nothing is there, just one. So one forward path is nothing, is there only one, okay. But how then I would again apply Mason's formula. So what is the delta? Delta is same. Delta will never change for anything, okay. So delta I am writing directly 1 plus gh. So this is your answer, because in this one, this forward path from input to output, is this loop is touching or not touching? Yes, this loop is touching at this summing point. This loop is touching at this summing point. This is a loop which is touching this forward path at the summing point. So that's why your delta 1 is 1. So that's why this is your E of S by U of S, 1 divided by 1 plus gh. This is a very known formula. But this is a directly you can find out. But suppose you want to find out indirectly, then what you do? After writing the first equation, you find out Y of S. Y of S is nothing but G divided by 1 plus GH into E of S. Then E of S is how much? E of S is nothing but E of S is nothing but what I have written is that this is input E of S, E of S, and here this error, okay, this error, this is the output Y of S into this one, okay, this is H of S, right, sir? What is E of S? E of S that this input minus this point, right, sir? इनपुट से इसको सब्सट्रैक्ट करेंगे तो ई ऑफ एस मिलेगा एंड दिस पॉइंट इज नथिंग बट योर वाई ऑफ एस इनटू एच ऑफ एस, राइट सर? आर यू
Sorry,
गेटिंग माय पॉइंट?
E of S is equal to 1. How to find? I not understand, sir.
Okay, you got this line, you got this formula directly, sir, fine. You're getting my point.
Okay.
I'm just removing this one, okay, you know the answers, okay. Now tell me how, from here y of s by u of s is the transfer function, then how will you come up to e of s? How will you find out e of s, sir?
E of S
From this
output.
block diagram, because this is
Out,
your y of s, right?
hmm.
So E of error is what? Error is nothing but the summing point positive minus the summing point negative, right? What is the
Yes.
summing point positive? E of s, right? What is the
Okay.
summing point negative? Negative is that this output y of s multiplied with h of s, right?
Yes.
You do that, sir. You'll find out your E of s. E of s minus y of s is how much? Y of s is g
So,
divided by 1 plus gh into E of
yes.
s into h of s.
Okay.
So take U of s common. So what you get? 1 minus gh divided by 1 plus gh, right?
Yes.
Now what is this? 1 divided by 1 plus gh, right?
Okay.
So this is your E of s. So the same answer is coming. So you can find out this way, and you can directly find out by using Mason's formula one line. That's what I'm saying, that if at any point if you want to find out the transfer function, you can find out, no problem.
Okay, sir.
Okay. So the question number 2 we have solved because these are some formula based. and you just apply. You should not miss any loops. You should not miss any product of two individual loops, finding out delta 1, delta 2. These are very simple. Let me focus on more on which part I want to focus. Uh, Let me find it out. Okay, so this question I have not written. This is a question about steady state error. Okay, so first question, let me ask some questions. Okay, so I'll tell you lots of shortcuts here. Let me find out what do you mean by steady state error. Okay, so first of all, tell me that whenever you are finding out steady state error for any function or any transfer function, so what is the first point? Steady state error is applicable to unity feedback system, or it is applicable to non-unity feedback system? My first question to all of you.
Once repeat the question.
So steady state error, because you have seen that the last question I have just taken one block diagram. Here this is your E of S, and this is your, let's say, Y of S, and this is sensing, I'm taking H of S, and here the summing point I'm taking a negative sign, negative feedback, and here is U of S. Now you know that here the error is E of S with respect to your input is nothing by 1 divided by 1 plus GH. Now I'm saying that steady state error, whenever you are finding out for any system steady state error, when it is applicable, whether the system is a unity feedback system,
Yes, sir. Unity feedback system.
or it is a non-unity feedback system.
Unity feedback system, sir.
So the first point you have to remember that whenever you are finding out steady state error, you are always, it is a unity feedback system. Let's say a system is given like this, it is a non-unity feedback system, then what you will do? Because see, whenever a non-unity feedback system is given, you have to find out the steady state error, because you are not the boss. The plant is already modeled by someone. At any transfer function, you need to find out the steady state error. Then how you find out? Because it's a non-unity feedback system. So what is the approach?
We have to convert it to unity feedback, sir.
Yeah, you have to connect it to a unity feedback system. It means you have to apply one positive feedback, means like plus 1. This is a positive feedback system, and again you have to apply negative feedback, minus 1. Then you have to take the transfer function gh with respect to 1, and then forget that non-unity feedback. You are getting my point, sir. I think you have to convert that non-unity feedback system to a unity feedback system by adding one positive feedback and one unity negative feedback. Got my point, sir?
Yes, sir.
Yes,
Suppose
sir.
suppose a non-unity feedback system we have find. So we have give the positive and negative system, negative signal. So unity feedback system is our getting.
Yes. Yeah. Like this, suppose this example you take, sir. You just take this example. G and H, it is there. Can you find out the steady state of this non-unity feedback system? It is not a unity feedback system. Then how we do? You first apply here one positive feedback plus 1, and let's say I'm taking this point, one negative feedback minus 1. So leave this negative feedback and convert this system, okay, this part, into a transfer function. So first tell me what is the transfer function of g of h. So I can write down directly g divided by 1 plus gh. Then what is remaining? What is remaining? One positive feedback. Positive feedback is there. So for positive feedback, you know this is a positive feedback. Then how you write down transfer function of this one? G divided by 1 plus gh minus g. This is the positive feedback system, and one negative feedback is there already. This one is minus 1. So now this is the transfer function, open loop transfer function, for finding the steady state error. You got my point, sir? You're not getting, then I'll tell you.
So this is
Sir,
the short.
please explain, sir.
So this is a shortcut method, or is the rule to
It is a
find the?
shortcut method, I'm just telling. Let me clarify, sir. Okay, because I am solving the question like this. Suppose you just understand, sir, this question. This is a very important question. Let's say G is given and H is given. Now First point is find out steady state error. Suppose they are asking in the question to you. So in your mind, steady state error you have to find out first of all for unity feedback system. Second point, steady state error you have to find out for a unity feedback system by taking the open loop transfer function, not the closed loop transfer function. This is a shortcut I am telling, sir. So what is your mind? Let's say this h you forgot. Then what is the open loop transfer function, sir? Open loop transfer function is g, right? This is open loop transfer function.
Yes, sir.
What is the closed loop transfer function of this one? G divided by 1 plus gh, right? Right, sir?
Yes, sir.
So whenever you are finding out steady state error, you take open loop transfer function, not closed loop transfer function. I'm telling the shortcut, sir. Okay, you got my point.
Yes, sir.
Yes,
Now
sir.
this is a non-unity feedback system. First of all, you convert to a unity feedback system. So what you do, you just let me change my color. Uh, yeah, you just apply a how you cancel. You have to apply one negative feedback. You have to apply one positive feedback. Okay, this one is plus one. This one is minus one. So then you have to solve this part because this part will gives your open loop transfer function. Okay, and this minus one is the feedback only. You just because steady state error is defined for the unity feedback system. So this minus one is a negative feedback system. Forget about that. You just solve the upper part. So upper part solving that, you know that this red part which I have shown you, this transfer function you know g divided by 1 plus gh, right, sir? Got it?
Yes, sir. Yes.
Now there in here one positive feedback is there plus one and negative feedback is there minus one. Then steady state error is valid for a unity feedback system. So let's say negative feedback system I am more comfortable. So keep this and solve this plus one. So how the transfer function of that one? G divided by minus g. This is the upper part. Upper part I am solving. This upper part I am solving, sir. This is the transfer function of the upper part. And what is remaining? Remaining is that minus one. This one is there.
Okay, sir. We closed loop system we convert to open loop system.
Yeah, means no, I'm not saying closed loop. Steady state error is you have to find out for a closed loop system by taking the open loop transfer function.
Yes, yes.
Okay, you are getting my point?
Yes, sir.
Yeah.
Once repeat again, sir, because a lot of noise.
Yeah, please, someone has to mute. Noise is coming, right? So, just one shortcut is there. Actually, how I am solving. Suppose G is there, and let's say this is the feedback you take. This is the feedback you take. Let's say this is I'm taking negative feedback. Then how I'm writing the transfer function? You just write down G divided by 1. Okay. Okay, if a negative feedback system is there, you have to write plus. If a positive feedback system, you have to write minus. So whatever this term is there, G, you have to multiply with this gain. This gain is 1 unity feedback. So write down that directly, G divided by 1 plus G. Suppose make it again, G divided by, let's say this transfer function is H. How will you have to, this is a negative feedback, then how you write the transfer function? Mostly in exams, in competitive exams, they will not ask you difficult question, they will ask you tricky question, simple question, but concept is there. So now you find out the transfer function of this one, write down the top, G divided by negative sign is there, so 1 plus multiply this 2 gh. You got my point? I have done here same G into 1. You got
Sir,
it?
feedback is negative. So
Yeah,
we connect the downside plus sign. Suppose feedback is positive,
then you
we
have to
connect downside
minus
in negative.
right,
Negative.
right. Like here I have done, sir. You can see G divided by 1 plus G minus G. Because G divided by 1 plus G is this transfer function. This transfer function G divided by 1 plus GH. and you have a positive feedback system. Positive feedback system. So what you do, first write that transfer function, g divided by 1 plus gh, write down, and then whatever is there, this is a positive feedback system, sir. So you have to write down minus, and whatever this denominator g, you have to multiply with this. So here, like that I have written.
Okay, okay, sir.
If you have solved by using formula, also you will get the same answer.
Okay, sir.
Okay. Let me give a questions to you. Okay. Suppose you have to solve and tell me the answer immediately. Okay. Let's say 100 divided by s into s plus 10, and here is 1 by s plus 5. Okay. This is the system. Okay. This is input. This is your output. Now tell me what is the steady state error of this one. All of you please do.
Sir, this 1 by 5 plus 5 or s plus s?
S plus 5, sir. S plus 5. S plus 5.
S plus 5.
S plus 5. First of all, this is a non-unity feedback system. You have to convert it to feedback system. Okay. So you know the answer is 1 plus g h minus g. This is your open loop transfer function. You need to find out this value. Then one negative feedback will come. 1. This is minus. Okay. So I need an open loop transfer function. So just to find out what is g divided by 1 plus gh minus g.
It means, sir, 100 divided by s bracket 5
Yeah.
plus 10. Uh,
So this is s
divi-
plus 10, sir. 5 plus 10. S plus 10. S into s
s
plus
plus
10.
s plus 10 divided by 1 plus
Yeah.
uh,
So this is
same.
100 divided by s into s plus 10 divided by 1 plus gh. So 100 divided by again s into s plus 10 with
Yes, yes,
h,
yes.
1 divided by s
Minus.
plus 5 minus g, again 100 divided by s into s plus 10.
Yes, 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 yes.
After finding this value, you need this open loop transfer function. And just tell me what is the answer. What is this value? Let I am writing down. I have written in my copy. This will be something 100 divided by s plus 5 divided by, this is a s cube, third order system, 15s square minus 50 times of s minus 400. This is my open loop transfer function. Now you just tell me what is the steady state error of this one when unity.
Sir, please, sir, explain how to write 100 bracket s plus 5.
Sorry.
The upper side, na? 100
Right. Uh-huh.
in bracket s plus 5. How to get, sir?
Or this one,
Yes.
you just need to solve this one. I'll solve it.
Yes, sir. I don't
You're not
understand.
getting the answer. Okay.
No, sir.
Okay, let me solve it. I am not solving. Let me. Okay. Let's say denominator is 100 divided by s into s plus 10. Okay. Let's take here this part. Denominator, how much LCM is coming? S into s plus 10, right? So s into s plus 10 is the LCM. S into s plus 10 is multiplied with 1. So this will be s square plus 10s. Then uh, s into s plus 10 into s plus 5 with the LCM, right? You have to take everyone because this s into s plus 10 into s plus 5. Here s into s plus 10 into s plus 5 is gone. So here 100 is coming minus So this part s into s plus 10 common s plus 5, so I have to multiply 100 into s plus 5. Got it now? So this
Yes.
into s plus 5
Yes,
is
yes, yes.
cancelled. I'll just simplify, sir.
Okay, okay, sir.
Uh, but my point is not here. This is a simplification part you can do. But my point is that now it is given in the question that it is a unit step input. Now what is the steady state error?
Positive.
So first of all, you say clarify that when input is step input, and you can see in the open loop transfer function what is the order of the system, sir. What is the order of the system?
C.
Order of the system is
Third,
3.
third,
What
three.
is the type of the system?
Type 0.
Type 0. So whenever type 0 system and you are applying input step means this is the general formula, sir. Input step means a into e of t, right? A is the amplitude of that. Okay, but here the coefficient of t to the power is 0. Okay, but in suppose I am saying this is for step. If it is a ramp input, then it should be a into t to the power 1 e of t. Okay, this is 1 means 1. Okay, then for parabolic input, this will be a into t square by 2 into e of t. Okay, like that. So this will be defined your input. If you see in a step, what is the power of t? The power is 0. In RAM, power of t is 1. In parabolic, power of t is 2. So how you define your steady state error? I'm just writing down here. Here this is my type, and this is your input, and this is your steady state error. Now tell me, sir, when type is let's say 0, input is 0. Input is 0 means t to the power you have to check. When input is 0, type is 0. Type is 0 means it is a step function. Sorry, type is 0 means what is the meaning of type, sir? Anybody can tell me? Number of poles at origin, right, sir?
Yes, sir.
So here in this open loop transfer function, number of poles at origin is 0. So that's why it is type 0. When these two are matching, then there is some steady state error will exist, remember. And you are taking input as unit step, whatever the steady state error is something a divided by 1 plus kp. Kp is called a position error constant. Now similarly, if it is 1, 1 means type 1 means RAM input. Sorry, type 1 means you have one pole at origin, like 1 by s into s plus 1. So s is at origin, so your type is 1. Okay, and here input is suppose ramp is means power of t equal to 1. When these two are matching, then some steady state error will come, and that is a divided by kv. Kv is velocity error constant. Similarly, when it is 2 2, acceleration error constant a divided by ka. Okay, this is valid for parabolic input. Now you tell me, suppose I'm just writing on the next slide. Okay, let me come here. This is input, this is type. This is an important concept for shortcut I'm saying. Okay, this is error. Suppose your this one is 1 and this is 0. What is the steady state error, sir? Type is 1 means it is a type is 1, you understand, one pole at origin, one pole at origin.
0.
Yeah, a steady state error is 0. Okay, remember that when your type is greater than input, the steady state error is 0. When is your type is less than input, your steady state error is infinity. When type is equal to input, you have seen the previous slide, then some steady state error is exist. Okay, and it depends which value. Okay, if it is 1 1 1, then 1 divided by 1 plus kp, or amplitude divided by 1 plus kp. If it is 2 2, sorry, it is 0 0, sorry. If it is 2 2, then it is kv, sorry, acceleration constant. Okay, a 1 divided by ka. If this is 1 into 1, this is 1 by kv. This is the velocity error constant. This is the acceleration error constant, like that. Got my point, sir?
सर जीरो के बाद में आपने डायरेक्ट टू क्यों लिया? जीरो के बाद में वन आएगा
I
ना,
just
जीरो
I
वन।
just have written, that's why I just sequence I have changed. It's not problem, sir. This is acceleration, I have written acceleration, this is velocity.
ओके।
This is step, this is parabolic, and this is your ramp signal. Got now it is clear?
ओके सर।
Now you tell the answer for that question. Here. Here you said. So for step input he's asking. Step input means 0 and here is type is 0. So 0 0. So what is the steady state error? Steady state error is A divided by 1 plus Kp. Kp is nothing but a position error constant when limit s tends to 0, g of s means open loop transfer function. Open loop transfer function. So here you just put s equal to 0 everywhere. If you put s equal to 0, the upper term will be 500 divided by the denominator will be minus 400. Okay, so this will be some minus 5 by 4. Okay, and what is the amplitude of A is nothing but the amplitude of the input amplitude unity step is given, so A equal to 1, so 1 divided by Kp you write down minus 5 by 4. What is the answer that you have to answer?
Please explain those comparison once again, sir.
Okay, this one
Yes, sir. Yes, yes.
just I'm giving an example, sir, to clarify you. Okay, let me give an
सर
example.
सर फोर टाइप्स ऑफ इनपुट ना, स्टेप, इम्पल्स, पैराबोलिक एंड
Yeah, impulse input is there, but for impulse input, whenever these are some standard signals. The impulse signal is not exist in practical. That's why impulse signal you cannot take at steady state. Why, you can tell me? This is a very important question you ask me, but I'm just asking. Suppose your input is in impulse. Can you find out the steady state error?
नो।
Because impulse is only exist at 0, it doesn't exist at infinity. Steady state error is that part of the response which is exist at t tends to infinity, right sir?
ओके ओके सर।
That's why not
It
taking
means
impulse
steady state error find only step, parabolic and
and
ramp.
ramp signal, because impulse is not exist at infinity. Steady state error means which is exist at t tends to infinity, right sir?
ओके ओके।
that's why that's why impulse
Sir,
is not taken.
sir, one thing. You have written type is
Yeah,
greater than input.
right.
It's listed as zero. And so please,
Yeah,
once again, sir, please explain this.
you just take an example. Let me give an example set to you. Okay, it's clarify actually. Yeah, let me write down here. Let's say, sir, I'm writing g of s 10 into s plus 1 into, let's say, s square into s plus 2 into s plus 10. This is the open loop transfer function is given to you. This is an open loop transfer function. Now your input is given. Your input, let's say, r of t is given 10 plus 5t plus t square by 2. Now what is the steady state error of this signal? What is the steady state error? So what you do, this type of question, how I solve, if suppose it is given in some GATE exam or some competitive exam, how I solve this question, I will write down like this. But I will write in my mind, okay? Just I'm just making you understand. Let's see type, let's say input, let's say steady state error, because I know some concept, because these are my observations. I already got the result from my observation. Let's say, sir, I am comparing type. So let's say this is which type system, sir? This, the question is giving g of s. What is the type of the system, sir?
Type 3।
No, type 2, because
Type 2
Two,
हाँ
type
सर।
two, sir.
yeah,
Type two.
we write down type 2. Why I write down 3 times? Because here are 3 inputs are given, 1 10 on is 5t and t square by 2. So you just write down when it is 2 2 to 2.
Once again, sir. What are the inputs, sir?
Say input is something given 10 plus 5t plus t square by 2. So 10 means what you can write 10 into t to the power 0 5 into t
Okay, sir.
power
Okay,
1
okay.
plus t square by 8. So meaning it is a combination of your step signal, combination of a ramp signal, and combination of a parabolic signal. So now you tell me, sir, suppose if I take 10t, 10t, if I take 10t, input I am taking 10t, then what is the input now? 0, right? When if you take 5t1, means t to the power 1, that's why input is 1. When t to the power 2, input is 2. Right, sir? Sir,
Yes, sir.
I'm taking individually. I'm calculating individually what is the response. Got it, sir? I told you
Yes, sir.
that
Yes,
when
sir. Yes, sir.
type is greater than input, your answer will be
Sir, sir,
0. Yeah.
sir, you solve denominator, na 0, 1, 2.
Denominator means, what is denominator you were saying? This is the input.
No, but 10t plus 5t plus.
Sir, how you find out
Okay,
the
okay, okay, okay,
steady state
okay.
error,
Input,
sir?
yes.
Yeah. You have to take individual response to find out the steady state because it's a combination of three inputs, sir. I'm not asking the question the combination of one input. It is a combination of three input. All the three inputs are there to find out the steady state error. Now tell me, sir, when your input is greater than, sorry, your type is greater than input, what is the steady state error? 0. When your type is greater than again 1, steady state is 0. So only for the last case, for this input, there is some steady state error will be exist. And that is your acceleration error constant, A divided by Ka. So you need to find out only Ka. K for of what? K is nothing but limit s tends to 0, s square times of g of s. Right, sir? So what you need to do, forget about this a square because this a square and this a square will be cancelled down. Just you put 0 everywhere. So what is that function? 10 divided by 20. So this will be half. So a divided by Ka. A is how much, sir? What is the coefficient here? A is 1 because t square by 2 is a standard formula. So A is 1. So 1 divided by K is half. So your answer will be 2. So for this case, the 2 value will be exist. Now you add all these things. 0 plus 0 plus 2. So your steady state error will be 2.
Sir, this 2 how to get? I don't understand, sir.
How you did this get 2?
Hmm.
Okay. You understand. Did you get that whenever, let me guess. Whenever 10 is applied, suppose individually you take, you are 3 students. First student you value 10. When you value 10, you take an input, your open loop transfer function is fixed. Now what is the steady state error is coming, sir? 0, right?
0, 0.
Whenever you take 5t individually and you find out the same thing, you have checked that 2 is greater than 1, again input is greater than, so type is greater than input, so steady state again is 0, right? Right, sir?
Right, right.
Now you forget this 2. Only t square by 2 is there. I know that this is a type 2 system. For type 2 system, what is the steady state error? That is derived in the class, sir. 1 divided by or a divided by Ka. K is called the acceleration error constant. For type 2 system, for parabolic input, this is the steady state error when these two will be matched, right, sir?
Okay, sir.
So here this is the standard formula a into t square by 2. But here a is not, a is 1 because t square by 2 is given. If it is given 5t square by 2, then you have to put a equal to 5. Right?
Okay, okay, okay.
And k is nothing but limit s tends to 0 s square times of open loop transform function. Just what is the open loop transform function is given here. You just multiply s square, this s square cancel. So put s equal to 0 and you find out that I am getting 1 by 2. So 1 divided by 1 by 2 is 2. Now you add all these things. This is 0, this is 0, this is 2. Got my point, sir?
Okay, 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 okay.
Yeah, that's it, sir. That's it. Let me someone to join. Is this part is clear? I'll solve more question. You are not clear. Just tell me. let me give another question. This is s plus 5 into s plus 10. This is your g of s is given. Tell me, sir, for first input, suppose I will apply 10 into u of t. What is the steady state error, sir? So what is the steady state error?
It's a by 1 plus kp, sir.
Yeah, a by 1 plus kp. How you know, sir? Because both are 1. Type equal to input, right? Your type is 0. Your and your input is step input. So t to the power 0. So that's why 0 and 0 is matching. So your answer should be a divided by 1 plus kp. And kp is nothing but the limit s tends to 0 g of s. So here 1 by 50. Kp is 1 by 50. So it will be answer will be 1 divided by 1 plus 1 by 50. But here a you have to put 10 because it is given 10. So 10 divided by 1 plus 1 by 50. Right, sir?
We can use directly formula steady state error like limit s tends to 0 s into rs upon 1 plus gshs.
So that you can do, no problem. But I'm just telling how can you solve easily by taking the open loop transfer function. By looking now, you are solving the question by looking the input and transfer function. You are not doing any formula. We are not doing any formula, sir. You got my point, sir. You can find out, sir, this es divided es by u of s equal to 1 divided by 1 plus gh, right? You can find out, sir, no problem. I'm not saying that you cannot find out. You here in this formula you have to find out 1 by 1 plus gh, then you need to find out e of s, then you take limit s tends to 0 e of s. You can find out, sir, no problem. You got my point?
Yes, sir.
Now suppose just giving another question. Just let me see here. Our second bit for this input, transfer function is fixed. I am just changing the input. Okay. Let me 10 into t square u of t. What is the answer? What is the answer? So you can see your type is 0. Input is how much? Input is 2. So when an input is greater than type, so answer should be infinity, right?
Yes, sir. Yes.
So no need to solve es by 1 plus gs. You can solve, so no problem. You can see your input u of s. You need to find out the Laplace transform of this one. Then you need to find out e of s by your input u of s. Then you have to take Laplace transformation, put s equals to 0 to find out the how much time it will take, and you can solve it this way. Have you cleared the idea about steady state error?
Yes, sir. It's clear, sir.
Okay, fine. Okay. So now I have some written some question. Now you can easily solve this question number 5. Tell me the answer.
Sir, it's not visible, sir.
Okay. Not visible by this time. It's not visible. Now it's visible.
Yes, sir. Yes. Okay.
Okay. Can I solve this question? Just in one line you just tell me what is the type of the system. So let me see how, whatever I taught you, how much time it would take to solve the question. Is my approach is helping you or not?
So I request to once again repeat the types of system input and steady state error like type 0, 1, 2.
Yeah, I will explain, but first you solve this
Uh,
question.
yeah,
First
yeah,
you
it's
try.
okay, sir, because no, I have doubts regarding this method. I'm not clear, sir.
You're not clear?
Yes, sir.
Oh, unless otherwise you're clear, you should not say yes. Okay? Because here what you are doing, we are doing research or we are reading some in some unless otherwise you are convinced, we are never say yes to a professor. So you also don't do
It's a
that.
type 0, sir.
How you know, sir? How much time? Why you taking a lot of time? Because you see, the unit step is given, right, sir? And your steady state error is exist. It means
Yes, yes,
it
yes, sir,
means
yes, yes.
it means
Same,
yeah,
same input and same
yeah. Steady state error
type.
exists. That's why the type of the system should be zero, right, sir? Because this is a unit step a into e of t. This is the standard unit step. Generally, solving the question, I am changing that it is a into t to the power 0 e of t. T to the power 0 is 1. So this 0 I am taking for my input. So when input is 0 and your type is 0, type means the number of poles at origin for the open loop transfer function. Type means number of poles at origin for the open loop transfer function. Because why I'm using these techniques to solve the problem? See, sir, I'm not finding out ES divided by RS, which is I told you in this class. Okay, how you find out ES divided by RS? See, sir, ES divided by RS, either you can find out output transfer function, then you subtract u of s minus y of s h of s, you'll get 1 by 1 plus gh. Otherwise, you can directly, those people are very smart, they will directly find out e of s by u of s is 1 divided by 1 plus gh. So how much time it will take to solve the problem? So that I don't want to solve the problem like that. Okay, so that's why I'm suggesting a method. The method is that you have to use open loop transfer function to find out the steady state error for a unity feedback system, and the feedback system should be closed. So it means steady state error you are finding out for a closed loop system, that to unity feedback, by using the open loop transfer function, not by using the closed loop transfer function. That's my method. Are you getting? This line is clear.
Yes, sir.
Means you say by
Yes,
yourself
sir.
that steady state error I'm finding out for a closed loop system, which is a unity feedback system, but not by solving the closed loop system, by only taking the open loop transfer function. But I am just seeing that the feedback system is should be a unity feedback system. I no need to solve the closed loop transfer function. I am just taking my open loop transfer function, I am solving the question. Because why I'm doing that? Because we know that my in my kp, in my kb, in my ka, because these formulas are like this: g of s, limit s tends to 0, is into g of s, limit s tends to 0, s square times of g of s. Here you see, sir, where we are using closed loop transfer function, you are using open loop transfer function. So why I should solve in closed loop transfer function by taking my killing my time? So I just use this concept. I need to take the open loop transfer function. So here you see, I've already discussed that when both input and type will match, then steady state error will be exist. You can check by yourself. Okay, you can take a equation like in the last in this I have taken here I have taken for this one you just see here your input is 2, your input is 2, here I have written input is 2. You solve, sir, by yourself you solve. Okay, and if here you say type is 0, if you solve then you will get infinity, you definitely will get infinity. So that's I generalized. That generalized means I am saying that when my type is greater than input, then my steady state error will be 0. When type is less than input, my steady state error is infinity. And when both will be matched, then that will be exist. That will be exist means when step will be there means 0 0. When 0 0 will matching, it gives my steady state error this formula. When 1 and 1 are matching means ramp signal, then it will give my steady state error by using this formula. Then parabolic 2 and 2 is matching. When matching, steady state error will be exist. So that's why these are the three formulas you need to remember. So that's why this question which I am giving to you, yeah, this is a simple question, sir. Because you see, unit step is given. Step means you have just written down a into u of t. It means t to the power 0. It means your input is 0. And you can check. Steady state error is 0.05 is given. It means it exists. When it will be exist, when this 0 and this 0 will be matched. It means if it is a step, then it will be a type 0 system. Got my point, sir?
Yes, sir. Clear, sir. Clear.
Next, you just use the formula because it's step input. So 1 divided by 1 plus kp. Error is given 0.05. Unit step is given, so a equal to 1. So what is kp? You need to find out the kp. That's the question. Oh, this is about the second part I solved, I think. Yeah. What is the position error constant kp? So you need to find out kp. Got my point?
Yes, sir. Yes.
So any doubt in steady state error? Because why I'm taking time here, because this part is important. This part is important because why, what steady state, how many, suppose a response is given to you, a response is given to you, c of t. In c of t, let me choose 1 minus e to the power minus t. Then tell me, can anybody tell me which part is steady state and which part is transient? Because there are two response. One is transient response, one is steady state response.
One is steady state, sir. E to the power minus t is transient.
Yeah, transient is something t tends to infinity, it will vanish, it will not exist, it means 0. Steady state error, which is a t tends to infinity, it should be exist. That's why for impulse input, we are not finding out steady state error. Okay. Shall I move forward for the next part? Time response. Shall you solve some question for time response? If this part is clear, then we'll move. If you have any doubt, then please ask. Don't say yes.
Clear, sir.
But one question I will solve, sir. This is a very tricky question. Actually, tricky question. Why I'm saying tricky question? Let me give a question. This is the last question of steady state error. Let me solve that. This is why this is a tricky question. We will find out what. Let me see. Let's give an example. G of s. 1 divided by s square into s plus 5 into s plus 10. What is the steady state error? What is the steady state error? This is type 2, right? With, it is with, uh, let's say 2. So let's say 5 into t square by 2. This is the input is given. This is the parabolic input is given. So what is the steady state error with this input? Can anybody tell me? This is the one question for you. Another question I'm framing by myself. Let me see. Just you solve by yourself. I'm just writing. So 5s s plus 10.
250.
Answer is 250. One is saying 250. So this is the standard formula, a t square by 2. So a is, you can take 5. It's parabolic input. So you are finding out 5 divided by 1 by 50. So it will be 250. Is everyone is okay? Uh,
Okay, sir.
this is 250, right? But in the
A
option,
by A by KA.
a by k, right? So answer is 250, right?
Yes, sir. Yes, yes.
But actually here I'm saying that the answer is not 250, sir. Here the answer is steady state error not defined. Means we cannot, steady state error we cannot able to find out. Not able to find out. Okay. Oh, everything is okay. I am also getting 250. Okay, but the answer is, you know how you get 250. Okay.
Right, we could not find.
Yeah, I'll tell you, sir. Okay, I'll tell you, sir. Just I'm framing one question to simplify
And
that.
how to check whether steady state is possible or not for a given
Yeah,
open
yeah,
system?
that's important, sir. That's the first point you need to check because you solved a lot of question. But why I'll discuss this last, because remember that the first point for steady state error, that steady state error, I just write down this note. Okay, steady state error. First point is that you have to find for a closed loop system, closed loop system by taking open loop transfer function for a unity feedback system, for a unity feedback system. Okay, condition, what is the condition is that, sir, the open loop transfer function is stable. This is the condition, sir. So open loop transfer function should be stable, sir. But actually what is happening now, this g of s, okay, this g of s, this system is unstable, sir. This open loop transfer function is unstable. Actually, why the stability part is not covered here, when you read RH criterion in the next week or in the next week, I will solve this question by using some shortcut. You should not worry about, because see, sir, to finding a stability, if I solve this question in 1 minute, then also I know how to solve this question step by checking the stability also in some seconds. Otherwise this way of solving question will take a lot of time. Anyway, in the reverse also, if you find out E of S by R of S, in that method also you need to check the system stability. First of all, steady state error is valid for a unity feedback system, that too a stable system. So you have to check the stability. Stability is not covered here. So RH criterion is not covered. So that's why this question is, you find out the stability of the system is unstable. That's why for unstable system, you cannot find out steady state error. So that's why the steady state error is not defined here in this case. So you just remember this question. The next class we'll solve the question. You also know how to find out the stability in one line. Just I'll not take more line. Just one line. How will find the stability. You just got my point, sir.
Yes, sir.
Yeah, you just remember
Okay,
this
sir.
condition.
How?
This condition you remember.
Okay, sir.
Open loop systems will be stable. Okay. Let's go for time domain analysis. I think we're running out of time. So all of you know that how to when a system is in time domain, that for a fast order system by taking different input. Okay, let's say a ramp input. Let's start with impulse input. Let's say for impulse input, for a step input, for a ramp input. Okay, so what is the steady state error? Can anybody tell me what is the steady state error here for a fast order system, or you can say for a 1 by ST system, means for type 1 system. What is the standard formula of type 1? This is ST. 1 by ST, you take a unity feedback system, negative. Okay, so this will be 1 divided by 1 plus ST. This is the closed loop transfer function. So all these are covered in the course. Okay, this is the time response you need to find out by using different input combination. Whenever you take impulse, when you take step, when you take ramp, so you will get some CFT output. So in that case, case also you need to find out the steady state error by using this formula. Okay, can anyone tell me? Just solve this question. This is a type 1 system is given. Type 1 system is given. What is the steady state error for impulse input? Not exists, right? Because for impulse, steady state error is not defined, right? Now let's go to the step input. What is the steady state error? So why we're taking a lot of time? Step input, I'm saying 0, right? Your type
Yes, sir. 0.
input, so answer should be 0, right? It means my system response will be something like that. Step means 1. It means at 5 time constant it has to reach the steady state. So this gap, steady state error, has to be 0, right, sir? Now
Yes, sir.
for a RAM signal, you tell me what is the steady state error? That is covered, sir, because these are the things we are not taking into consideration while we have go through the course. So first tell me what is the steady state error for RAM signal, sir? RAM means you are applying some input here, T. This is my
The
input T.
constant T.
Yeah, it should be constant always. Okay, and that constant is how much, sir? Your time constant.
Time constant.
That you need to remember.
Time constant, sir. Too.
Yeah, for RAM time constant. Yeah, it is one case they have given this example. When it's a question they have asked in the gate exam, that for RAM signal they have given this signal and they have to ask what the steady state error in terms of time constant you have to find out. And you know that for this closed loop system, what is the time constant, sir? 1 by ST. What is the time constant? Or what is the pole location, you tell me, sir? What is the pole location? 1 plus ST you make
It's a,
0, sir. So S equal to minus 1 by T, right?
yes, sir.
So time constant is nothing but minus 1 by S. Okay. Okay. Now you got for let's say go to second order systems. What is the second order system standard formula, sir? Omega n square divided by s square plus 2 zeta omega ns plus omega n square. This is your C of S output divided by our input R of S. Let that you take. Is everyone is know that how it comes? How you derive that? What is the second order system? Open loop transfer function. Omega n square divided by S into S plus 2 zeta omega n, and it is given to a unity feedback system 1. This is your input R of S, and this is your output Y of S, or whatever C of S. Can you, using block diagram reduction, can anyone got this answer? Directly I'm saying directly, because
Yes, sir.
directly write down omega n square divided by S into S plus 2 zeta omega n. Just you multiply this one here, omega n square, okay, into 1, because 1 is h of S. So you will get this formula directly. So for this transfer function also, you have to find out various types of input combination. For ramp signal, step signal, and for parabolic signal, you have to find out the system response, and you have to find out the steady state error. Okay, so now for this second order system, whenever you are applying a unit step input, you have different thing you have to find out, because whenever you are applying this system, then sometime your response will start and it will oscillate, and another time it will reach the steady state. So here some peak time is defined, some delay time is defined, some rise time is defined, some peak overshoot is defined. So all these things are discussed in the classroom. So based on that, I'm giving one question. Let me give one question. You just, everyone just write down this question. Example: the unit impulse response, the unit impulse response of a unity feedback system is given as e to the power minus 3t sine 4t. First question: closed loop pole location you have to find out. Second bit: what is the time constant? If you know the time constant, then find out the settling time also. Settling time. Then you have to find out the percentage peak overshoot and delay time. How can you solve this question?
So e to power minus 3t sine 4t is the CT.
No, it is given as, you read the question. Unity impulse response of a unity feedback system is given, means this is your C of t is given to you. Because C of t divided by unity impulse, na sir, when delta you have take Laplace transformation, that will be 1, right? So that is C of t, e to the power minus 3t sine 4t. And what is C of S? This is your overall response. Okay, overall response means C of t divided by R of t. Okay, but R of t is your impulse input. So whenever you find out C of S by R of S, R of S is 1 in this case. So directly you just write down what is the Laplace transformation you know for this signal. This will be sine, so 4 divided by S square, or S plus 3 square,
S plus 3
S
square.
plus 3 square plus 16, sir, right? R of S is 1. Sorry. You got my point, sir? How you find out this transfer function?
Yes, sir. Yes, sir.
Now tell me the first question. What is the pole location, sir? What is the pole location? Pole location means this is C of S given as such. So only you just take the denominator, S plus 3 whole square plus 16 equal to 0. So S is how much pole location you will get? So S1 is how much? Minus 3 plus minus J4. So these are the two pole location.
Yes, sir.
Okay. So when the question is given in front of you, to arrive at this, it will take hardly, sir, 1 minute. But when the question is given to you, looking at the question, you can say that the pole is minus 3 plus minus J4 in 5 seconds. How? Because you need
It's
to find out the Laplace transformation and solve it, you will get this. But by looking at the question, you have to write this in 5 seconds. For that, you need to know the nature of the poles. When this poles is given, sir, minus 3 plus minus J4, this minus 3, this minus 3 is called the transient part, sir, right? And this J part is given here, uh, this is called your damping time, damping. So that will always come with this coefficient here, and this minus 3 is that coefficient here. This is in detail, sir. Actually, you have to go through in
Please
detail.
once repeat, sir, this thing. E to the minus 3 t related to minus 3.
Okay, okay. Hmm. Actually, sir, what is happening? How can I explain you? E to the power minus 3t into sine 4t, let's say. Okay, this question is given to you. Then, have you, sir, know about differential equation, different pole locations? This is a differential equation solution, sir. When a differential equation is given, this e to the power term, sir, always gives you the real part. Are you getting my point, sir? Have you
Yes, sir.
remembered differential equation to solve how differential equation with distinct pole and differential equation with repeated poles at same location? Then how it will be complex. If you know that concept, na sir, then you can able to uh, uh, tell this answer. Otherwise, it will be difficult. I cannot explain or if you don't know differential equation. So it is a differential equation. From differential equations it is coming. So differential equation, this e to the power is nothing but the real part always. So that's why I'm directly saying this is minus 3. And in differential equation, sign is coming means definitely the complex term is coming. And whenever a system is complex means it always exists in complex conjugate. So that's why this 4 is nothing but your imaginary part with a complex conjugate. So minus 3, one pole I have taken J4, another pole I have taken minus J4. So based on that, sir, I had this scheme. So that's why I'm saying that by looking at this, you can solve this question if you have idea of differential equations. So please revise differential equation so that you can write down in one step. Got my point, sir?
clear, sir.
Yes, sir.
Sorry.
Yes, sir.
Okay.
Got it.
Next me. What is the time constant, sir? Now you can looking because this question will take 5 seconds to solve. Now from here to another 5 seconds. What is the time constant, sir? Sir, in step response na, when this pole is coming na sir, for a step response of a first order, second order system, because this is second order system is given s plus 3 square, then you know that this pole is something like say minus sigma plus j omega t. This is in term this term, sir. So this sigma is nothing but minus 3 here, means 3 here. So whenever a pole is given, remember that the time constant is nothing but the negative inverse of the real part of the pole. So real part of the pole is minus 3. So the time constant is 1 by 3. You got my point, sir?
Means time constant is the
Negative inverse of the real part of pole.
okay, okay. This is inverse of the real part. Cool. Okay, sir.
So this you can see, sir, here I have just derived. Time constant is the negative of the real part of the pole S. We have just defined for a first order system. For a second order system, it might be complex, but you have to take the real part. You got the point, sir?
Yes, sir.
Now you got the time constant. Now settling time is nothing but some 4 times of time constant. So multiply 4 here, right, sir? Are you following, sir?
Yes, sir. Following.
Now you tell me what is the next part is asking you find out the damping factor, sir. What is the damping factor here? In this equation, what is the damping factor? So you know, sir, whenever a second order system is given, so this will be some minus zeta omega n plus minus j omega d. Omega d is omega n into 1 minus zeta square. This is for a step response, right, sir? So I'm just simplifying it, minus zeta omega n plus minus j omega n into 1 minus omega d, nothing but omega d, damped frequency of oscillation. Okay, and this minus zeta omega n is the real part. So real part is given, sir, minus 3. Imaginary part is given 4. If you take the real part and the imaginary part, if you find out the amplitude, that will gives you, means here, minus zeta omega n square plus omega d square. If you take the square root, that will gives you omega n, right, sir? That you have already discussed in the class. And it is nothing but a circle. Okay, if this is your minus zeta omega n, if this is your omega d, then this whatever the area of the, sorry, the radius of the circle is nothing but your omega n. It means the hypotenuse. So this hypotenuse is your omega n, right? So by looking at this, I can say that my undamped natural frequency omega n is nothing but 5, because 3 square plus 4 square square root is 5. So omega n is 5, right, sir? You cleared this point?
Yes, sir.
After taking omega n is 5, you know that zeta omega n is given 3. Zeta omega n is given 3 because real part is denoted by zeta omega n, which is 3. Okay, so omega n is 5. So zeta is your damping ratio, which is 3 divided by 5. Sir, I am not solving anything. Just I am looking at this equation. I am writing down all the answers. What is percentage peak overshoot, sir? Percentage peak overshoot formula you have to remember. E to the power minus pi zeta divided by 1 minus zeta square into 100%. This is a percentage peak overshoot. You know zeta. This is the previous slide. I have find out 3 by 5. Zeta is 3 by 5. You put in this equation and find out percentage peak overshoot. You find out rise time, sir. The rise time formula is how much? What is the rise time formula, sir? Pi minus theta divided by omega d. Theta you need to find out, sir. Because this is
Cos
real
inverse.
part. Zeta omega n is given. This is imaginary part. This is your omega n. So this angle is your theta. Okay. This is your j omega t. So find out theta. Theta equal to cos inverse zeta omega n. That should be in radian, remember. Because you are subtracting something from pi, it should be radian because pi is radian. I think that there are lots of things in time response. If I take another 2 hours also, lots of things are there. But Time is limited. How you, by looking at the graph, how can you say that the system is critically damped, over damped, under damped? By just graph, no need to solve anything. Just by looking, you can say.
Sir, please explain the previous slide, sir. Finding
Which one you find? Which one you want to
uh, this one, sir. How do we get omega n is equal to 5?
know? Okay, omega n is 5, sir. Actually, na, this is a second order system, right, sir? Because
Yes,
this is
sir.
plus theta whole square. So whenever a second order system is given, it means the transfer function is a square plus 2 zeta omega ns plus omega n square equal to 0, right, sir? So if you solve this equation, you will get s1 equal to minus zeta omega n plus minus j omega t. Omega t is your damped frequency of oscillation, which is nothing but a natural frequency of oscillation into 1 minus zeta square. So if you want to draw this, minus zeta omega n is the negative part, j omega d is the imaginary part. So this will be omega t, this will be zeta omega n. If you find out the hypotenuse, then that will gives you omega n, right? This is this is
Yes,
this
sir.
this is just a
Yes, sir.
Pythagoras theorem applied. So
Okay,
this
sir.
is omega t. This is 4 is given. This is 3 is given. So omega n is 5, sir.
Okay.
Right. Sir. That's right. Now we can solve this question. This is also a second order system, sir. Because s into s plus zeta omega n is given. Right. Now I think you can solve this question. No problem. So first you write down the closed loop transfer function, sir. G divided by 1 plus gh. Right? H is 1 here. So in my shortcut, how will you write it? G divided by s square plus 3s plus g. Because whatever this g is there, you just multiply with this unity feedback, right? How you write down? I'll just tell you again. First you write down the same thing, whatever is given in the denominator. S square plus 3s. Then whatever this numerator, you have to multiply with this h of s. H of s is 1 here. So here is g directly. So this is a closed loop transfer function, sir, right? Now you have to compare this closed loop transfer function with s square plus 2 zeta omega ns plus omega n square. If you compare, you will get omega n square equal to g and 2 zeta omega n equal to 3. Up to everyone is clear?
Sir, second step is g upon s square plus 3s plus g. You are adding g.
Because it is a unity feedback system, right? Sir, you just find out by yourself. G divided by 1 plus gh.
Okay, sir.
If you solve, you will get this one. I am not solving because I know how to apply the shortcut here. Because I told you the shortcut. When first you write the same thing, g. I have written the same thing, g divided by, I'm just splitting it, s square plus 3s. Then I told you whatever in the numerator, this numerator should be multiplied with this h of s. Here h of s is 1 because unity feedback. So g is multiplied with 1. Write down here, sir. If it is a positive feedback, then you have to subtract this. This should be minus g. But here it is negative feedback is given. That's why I have written down plus g.
Yes, sir.
Other
Directly.
directly
Okay.
you write down. Otherwise, you can solve this formulas. Find out the closed transfer function. Up to everyone is clear.
Yes, sir.
Now percentage peak about should what is the formula we told you, sir? E to the power minus pi zeta. First of all, transfer function is clear, sir. In this question, he's asking the find out the transfer function. So transfer function, I think this one is the answer, right, sir? Next, what is this peak overshoot? You just see from this graph. What is the peak overshoot MP? Unity feedback is given, right? So unity feedback is given from 1 to this distance is how much? 1.5266 minus 1 it means 0.5266 is your percentage peak, not percentage, only your peak overshoot. So peak overshoot. MP is this much. Okay, MP is just the difference between this 1.5266 minus 1. This will be 0.5266. This is your MP. You got my point, sir? Shall I move?
Yes,
Next,
sir.
find the value of g so that the closed loop response for a step input are shown in figure. So you have to find out that g value first. How will you find out g? Sir, g is nothing but omega n square, right? So here you
Yes,
apply
sir.
this formula, percentage peak overshoot is e to the power minus pi zeta divided by 1 minus zeta square. Okay, so here percentage peak overshoot, here in place of this you write down this one is 0.5266, then minus pi zeta divided by 1 minus zeta square. There should be some ln of 0.5266. After that, here you find out zeta. The zeta value here is something 0.2 you will get.
So directly, sir, as we have got. Okay, sir. Okay, okay.
Ah,
Omega n is not known. Okay, sir.
right. Omega n is also not known.
Yes, sir. Yes, yes.
Then how will you find out g, sir?
We have to substitute. We have to first find zeta.
Zeta you got, sir, 0.2.
Omega n we have to find. Then omega n square will be g.
Right. How will you find that?
Omega uh, 3 by 2 zeta is omega n, then
Right.
we will take the square, that will be g.
Right, sir. Right. You just solve these two equations and find out.
Sir, this is a graph of underdamped, but how critically damped graph look like?
Yeah. What do you mean by first tell me what do you mean by critically damped? Critically damped is something like that means you are saying critically means what? Critical means critically that system is reaching steady state, right, sir? Critically means under damped system it has to
Someone,
under.
when the mic, some noise is coming.
Yeah, please unmute. Okay. First to solve this question, I'll tell you. First, third bit is remaining. Uh, what is TS and TP? TS and TP means what is peak time and settling time, sir. Peak time formula is what? What is peak time? This will be pi divided by omega d. Okay, sir. Pi divided by omega n into 1 minus zeta square. settling time for 2%. For 2%, what is the settling time? 4 time constant. 4 time constant. It will be 4 times of 1 by zeta omega, because time constant is 1 by zeta omega, negative part of real part of 4. Got it, sir?
Sir, how the time constant is concerned?
Sir, for 2% tolerance is given, right? For 2%, you have settling time is 4 time constant, right? For 5%, it should be how much? Suppose it is not given 2%. Suppose it is given 5%. Then what is the settling time?
3 by J omega n.
Right. 3 into 3 into t. T is equal to 1 by zeta omega n. Right, sir? This t is nothing but zeta omega n, because the pole location I told you, na, is equal to minus zeta omega n plus minus j omega n. You have to remember this, sir, for a second order system. Negative inverse of
Okay,
that
sir. Okay.
real part is called your time constant.
Okay, sir. Clear.
Yeah. I think it is clear. Okay. So let me clarify one person's doubt. Then we'll stop there. If you have any doubt, you can reach to me. Okay, in my email ID or somewhere. Any doubt, any questions? Okay. Because time is less here, and this part is actually a little a lengthier part. Steady state response, time response. So you have to solve by yourself as much as question. And if you have any doubt, then you can call me, or you can just text me in my WhatsApp or mail me. Okay. So now one person,
Small doubt, sir.
yeah.
Sir, in the survey of the this problem solving session, your name is asked and the email ID is also required, sir. Your email ID.
Sorry, sir. The email ID means?
In survey, they have asked a name. Then next line is this, email ID. Our email ID is already displayed. Then we have to write your email ID, I think.
Oh, my email ID. Okay, I don't know. Uh, because my email
Okay,
ID is
sir.
this one. I have just given my IIT Bombay email ID. This is my roll number here at the rate iitb.ac.in.
Okay, sir. Okay.
Okay, so one person
Okay.
asked me what is the difference between a critically damped system, an over damped system, and what is an under damped system. So whatever the core you are seeing here, that is definitely a under damped system, because to reach the steady state, it has a many oscillation. So many oscillation you have to produce. Okay, high peak, then low peak, then it gradually it is decrease and reaches the steady state. But if the system is critically damped, आप has to understand critically damped के बीच में आंसर लिखा है भाई. Critically damped means critically it will produce one oscillation. Over damped system means it has overcome the oscillation, means there will be no oscillation produced. You got my point? Critically means it has to critically बहुत कस मतलब उसको मेहनत करना पड़ेगा. You have to produce one oscillation. So the graph will be how the graph will be looks like if you have to critically produce one oscillation, something like this. But if you have to overcome the damped oscillation means you have to definitely you cannot produce any oscillation. So it will be something like that you have to produce. This graph will be something like this. You will not produce any oscillation. You have to reach the steady state without any oscillation. Under damped means you have to multiple oscillation you have to make and reach the steady state. But hardly here in critically hardly you produce one oscillation. Maybe or may not be. Sometimes this graph will be come here and it will be reached like this. Sometimes it will come and close to the here, but it will hardly produce one oscillation. That is called a critical damped oscillation. Any doubt?
Yes, sir.
Yeah. And the critical damped means you have to read, okay, how the poles will be real and repeated, means multiple poles at the same location. That will be gives you critical damp. Over damped means in real axis the pole are different locations. In overdamped case also you will find out which one is dominant pole, which one is away from your origin, that is a far pole. So sometimes we are ignoring that far poles when solving the question. That is called dominant pole approximation. You have to take only the dominant pole, because in second order system you have two poles. Whenever you have doing your overdamped, in overdamped you will get multiple poles on the real axis but at different location. So sometimes one pole is closer to the origin, another pole is far away from origin. It means more than 5 times constant distance. So that pole sometimes you have to ignore in overdamp case, and you have to take only the dominant pole, and that is called dominant pole approximation. So these are the things you have to read a little bit by yourself, because these are the things question will come in some competitive exam. Preparing or not preparing, then also you should know. So any doubt you can free feel to ask me. Okay, this is my email ID I told you, and this is my mobile number. Okay, so you can send me your query here in my WhatsApp. I'll definitely reply you. Okay, within 4 5 hours, and otherwise you can communicate me my email also. So I am stopping this class because I have overtaken 10 minutes more. So if any doubt, then you can come to any point of time. Okay.
Thank you, sir. Thank you very much.
Okay. Okay. Good night to all of you.
Good night, sir.
Thank you, sir.
Yeah. Thank you so much. Thank you so much.
Thank you, sir.
Thank you so much.
Thank you, sir. Good night, sir.
Yes, sir. Good night, sir. Thank you so much. Yeah. Yes, sir. You can leave now, sir.